Wow.
Like fellow fabricators, I'm always interested in tools that make my fabrication easier, more precise, and cleaner. I remember decades ago when I bought my first handheld plasma and how that made life easier compared to oxyacetylene torches. Then it moved on to CNC Plasma Tables, and for the last 15 years I've enjoyed the ease of use and able to get parts that are more precise than hand cutting could ever achieve. But I've always lusted over fiber lasers, and fiber lasers from a price perspective always seem to be out of hand. Well, with these fiber systems from China, you can now build your own system. Well, with the fiber source, the chiller, and the head, that price was building, and then the time needed to wire everything up and put it on a table just made me sit on it, not motivated to get after it. Well, like many of you, I've also seen these fiber laser welders and amazed at what they can do, and always thought, man, that would make my fabrication life easier too, as it welds faster, it welds cleaner, and it welds pretty much anything. It can weld copper, stainless, mild steel. So I kind of sat on that also, but then I saw these videos that you could actually cut with these systems too. And then I had this great idea. It's like, well, why can't I buy this multi-use system that basically has all the parts put together for a fiber system and then put it onto the table? So I bought one.
So here's a little overview of the unit. It's a 2000 watt fiber laser. Bought it off Amazon, and I did that because I kind of wanted some security of if something showed up that was broken, I could maybe have a refund or whatnot. But the company that I bought this from does have a representative from America, so I was able to contact him to basically get updated starting instructions, and I'll show you what needed to happen for that. They need to update their manuals when they ship these. But a lot of these units, from what I can tell, are all using parts that are sourced, and then they're just basically assembling them together in packages. So they all kind of look the same. They all are using similar sources, similar laser sources, similar computers to run everything. Basically what happens is this 2000 watt unit was the biggest one I could find that would run off 240 volt single phase, and they're advertising it that you can weld single pass 3/8 inch. I think it probably could do a whole lot thicker than that. A lot of power coming out of this, and it comes with the wire feeder. And here's the gun. It's how you use this to adjust the focus, which still is kind of playing with. But I've been using it for, I probably welded a good, and then this is the ground clamp per se. It's not, but basically what it's doing is you put it to wherever you're welding, like a table, and it makes sure you don't activate the laser unless this tip is contacting that. Sometimes I have to basically connect it here so that I can get to a weld that's kind of hard to get to. But it comes with tips that you can use, 035 wire. They recommend a lot of nitrogen. This is very pure nitrogen for welds. I found that you can also use compressed air for welding mild steel, and impressed with how strong that is for what it is. You can tell that the weld might be a little bit more brittle, but the weld quality seems to be, there's no oxidation, there's no porosity, and then there's some papers that I can link to in the description that shows that it's as strong as a normally shielded weld with, say, nitrogen, but it is a little bit more not resistant to fatigue, or basically it becomes brittle. Let me show you how I turn this on. I'm using just a micro guard. I have compressed air that has the refrigerated liquid, refrigerated condenser to get the moisture out, but I put this in it because the air has to be really clean and void of moisture so it doesn't screw with protective lenses. So that's a micro guard sub-micron filter that filters out the particulates and moisture also. So to turn this on is kind of interesting. They have this that you pop out and it turns the computer on, and then you have to come down here and turn the chiller on, and that turns the pump on, and it has a chiller and a heater in it. The water needs to be above 20 Celsius to even let the laser turn, and then turn on, and then they recommend 28 Celsius and below for the actual operation. So this thing cycles quite a bit. I kind of wish it didn't cycle as much, but so it has cooling tubes that goes to the laser source, and then a couple cooling tubes that actually, come to the head themselves, and you can see them right there. So it keeps all this cool. And then after you turn that on, turn the condenser on, or the chiller on, then you turn the main power source. And then this is where I had no instructions, but I had to basically get online. So you see there's a red light in there, and once that red light is going to turn, it's going to flash red and green here in it takes about 30 seconds. And once you do that, then you can turn, there's a breaker, this red and green, and then it's right there, and then you have to open this up and then turn this on to activate the laser. And it has to be done in that step or it won't work. And let's just say I was freaking out when I first got it, because it would put out a red laser beam here, but when you pull the trigger it did nothing. So I was able to get in contact with them. They got in contact with me pretty quick after I had to download a WhatsApp and get their numbers, but they got me through it. And of course there's videos online. It's a very generic screen of how that works. Comes with presets and things of that nature. Like you go here, I don't want to say that, carbon steel 2.0 export, and it brings in all the settings. There's the chiller coming on.
Here I'm cutting out the bracket with the CNC Plasma Table. This bracket will hold the welding gun, or cutting gun now, fiber laser, to be mounted onto the table itself. I really like this metal brake, magnetic metal brake. It really makes bending these small brackets pretty straightforward and easy, quick. Has all sorts of attachments. Here's the bracket that goes around the gun. I have a little lip for it to keep it from moving down. And here's some welding with the fiber laser. I really like it with these small nuts and such because it doesn't put a lot of heat into it. Still getting used to it. You have to let the wire kind of push the gun and not fight it. It's hard for me to do right now, but it makes a very clean weld. And I'm just using compressed air for the shielding gas right now, which is around about 25 psi through the regulator. Very nice weld, clean, no porosity. As you see, it penetrates very nicely.
So for electrical, I had to figure out how to basically activate this switch from the computer, which is, plasma on. So I took this cover off, traced the wires back to the unit. Let's open up the unit here, and basically I put this, I use these jacks because they're nice and they're protected when you're not using them. But on this control unit, I was able to find start and ground, and was able to put this jack in so I can connect to my control box for the plasma on, which starts the arc. And in this case, it will start the laser arc or laser beam. So it comes with this cutting tip. Slower than the plasma torch. So we'll see. So I want to go through the settings here. From what they said to the manufacturer, you put the cutting wattage. I'm going to start out 1500, but then your wobble length needs to be 0.1, and that's all they send to get this thing in cutting mode. Of course, you have the head on there with the cutting nozzle. They give you a very wide range of air pressures, but I just have shop air at probably 110 psi into it. And then there's our signal wire to turn it on from that bird nest of wires, which is the back of it's the control box to here is the connection to have it to turn on. There's no arc voltage, right? So we'll have to figure a torch height control later in a different video. Also, make sure your plasma cutters unplugged from the control box. Notice that if you keep that plugged in, then it actually might trip that on. So I got a program for a bottle opener that will see if that works. Also, safety first. These are the glasses, laser glasses that they sent. Wear them. I've noticed that this thing does put out laser beams in places, especially when you're filming it. You can't see it by your eye, but when the camera sees it, it's kind of a purple flash. So you've got to be wearing these. The actual laser tables that you buy have on the closer, and probably for a good reason. So there's no one else in my shop, no animals, no dogs, but wear these. All right, now we try it. Ah, it's working! Wow. Heats up the back of that plate pretty good. Wow. That focused. Wow. Look at that. I'm gonna try to take it out. That pops right out. Can you see that? I'm gonna have to work on the settings some. It's warm. But the kerf width is small. Got some slag on this, so I'm gonna have to figure out. It might be focus. It might be, man. Look at that. Let's take a picture of that. Wow. Wow. Look how small. I don't know. I can't get it. The kerf width is that. Alright, we're doing 1/4 inch at 40 inches per minute at 2000 watts. What's doing that for? So it's leaving a lot of slag. I think it has to do with the focus. You know, leave in the comments. But that's 1/4 inch steel. Man, it cut all the way through 3 sides of that, and it's a little warm, but not on that downward side. The only thing I could think of is I didn't really have it flat in there. I just had a clamp on it, so I'm thinking maybe it got over here and got way out of focus for some reason. But then it started cutting fine over here. So I think that's when the torch height control is going to come in handy. But man, it will cut through 1/4 inch steel. Maybe y'all, any laser experts out there, can tell me, you know, do I need to bring the focus down, up? How do I get rid of that slag? Is it more air pressure? Let me know. But I'm impressed with it. I mean, that's a whole lot better of a cut than plasma can give. So I have 2 options for the torch height control. So how these work is they have a ring that basically, and he's got 2 of them, that the torch will sit into it like this. And this ring uses capacitance. And capacitance is basically the electrical potential between 2 plates. So this is using an area, and it's going to use the area of your plate, and then that's going to determine how high or low the actual torch height or laser torch is off the material. And these are used a lot with oxyacetylene torches. So my idea is to put the laser torch in there. That way this can be independent of the actual hand torch, and we'll have the ability to basically follow plate. My 2 options are, this is a capo 4 capacitance height control. So this is basically how you adjust the torque side control. This is, you know, they supply a pretty small cable to go from basically these to this. So this has to be close to the z-axis. So you're going to have to be able to adjust this while the machine is close. I guess you can adjust it without, you know, actually cutting anything. But there's also, you know, another cable, and there's some adaptive circuit boards here, so you can connect it to your breakout board. So that's the first option. Second option I have is this one, and it's and I'll put links in the description, but this is a OHC 32A02. Same thing. I think it has to be close. Here's the actual mount. So we'll have to modify that to work with whatever. This has a little bit of a spring to it, so I guess when it hits, if it hits it, it can give a little bit. This is the one I'll probably try first, just because same thing, it has a short cable to go from there to here, so this has to be mounted on the z-axis somewhere. I think it takes 24 volt DC, and I think I'm going to use this one first, just because it seems like it has the option. Just basically those are your connections to your breakout board, and then here's your connection to that, and then that's all you have to do. And then it has this remote, basically potentiometer. So I might want to, I don't know, I could actually put this on the side of the gantry, so it might be easier to get to. But I don't know how, this cable is only about 3 feet long. So I might open this up and extend it, because it's only 3 wires. And if I do that, I might be able to just put it by the computer where my other torch height knob is, to be able to adjust that. Interesting thing, and these have different modes. So I'm just wanting an up and down signal basically for the breakout board, but also I think both are capable. You could actually wire this in line, so it has direction, step, actually, yeah, pulse. So basically this allows you to wire it in between your z-axis, between the breakout board and then your actual stepper motor controller. So I don't know why you would want to, maybe if you didn't have any more inputs or outputs on your breakout board, this would let you basically you know, add it in there without having to take up any more inputs or outputs. So I devised this very crude bench test, and as you can see right here, it's happy. And if I go down, it gives me a signal to go up, and if I go down or up, that's where it's happy. I'm shaking it a little bit, and then it wants me to go down. That's it moving. And then this adjusts it, so basically right makes it want to go down, so now the down's activated. And so if you go down and it's satisfied, you know, wants to go up. So it's very sensitive, which is neat. And then I've ohmed these out, so they make a connection in relationship to this. So making these connections in the breakout board for up and down should be pretty good. So my very crude bench test seems like it's working. And the neat thing is like it can go way up. Like I had it like an inch up, or it could go really down. And apparently, when you hit it, it has a collision, and it's supposed to make it go up. So from the bench test, it looks like it's working fine.
This is how I mounted the capacitance sensor. I used a hose clamp, tack welded it to the fiber laser head mount. This allows me to take the whole assembly off with the fiber head laser so I can still use the plasma cutter. This also lets me adjust the height of the capacitance ring in relation to the fiber laser head. I wanted the fiber laser head to stick below the ring so that the fiber laser could get as close to the plate as possible. This caused problems because the head could touch the metal and the collision sensing of the torch height control would not sense the touch as they weren't connected. This caused problems with the edge of the plate as I could only get a certain distance to the edge of the plate before the ring was not sensing enough and would cause problems. Also, I wanted to be able to make sure that the head, if it did touch something, would activate the collision avoidance to raise the whole head up and just not the ring. This was as close as the edge of the plate as I could get for the torch height control to work, and as you can see, I was raising the plate towards the head and then dropping it, and the torch height control was following the plate. After this, I raised the head up to be above the ring and noticed that I just could not get, with this setup, I could not get the head close enough to the plate to be effective. Here are the settings for the torch height control. U is for the set point from the potentiometer. This is for the area of control. This is for the sensitivity. This is for the delay after it gets the start signal for the OK to go signal. This is also a steady state error. I don't know what the 001's for. And P is for what the sensor is actually seeing, and it has to be in these dashes for you to have it operate. I'm impressed with the cut quality and how perpendicular the cut edge is to the top of the plate. I still have light dross on the back of the plate and want to get the nozzle closer to the plate to try to alleviate this. So this is my test setup to try to get rid of the ring on the torch height control and just use the nozzle itself. And I was able to get it to work, but knew that I needed to make a isolator instead of the stainless steel tube that came with the head. So I used this, I made this one out of plastic first to test, and then I acquired this machinable ceramic, 3/4 inch diameter, and it machined okay, chipped in some places, but 3/4 inch really wasn't enough wall thickness for where the nozzle went into the ceramic. But it worked. It worked with this setup. But the sensitivity just was too high. I believe it was just because there was not enough area in the brass and copper nozzle. So what happened was I ended up moving around and not paying attention, and the ceramic broke by the torch height control ramming the nozzle into the plate. I have another piece coming to redo this, but I switched back to the plastic to go to this next setup. And basically I'm still using the ring, but tying in the nozzle into the ring with this little clip. That way the nozzle can get below the ring, and since the nozzle actually hitting the plate, but having enough surface area in the actual ring itself to keep the height. And this is actually working pretty well. And it works pretty well when it gets close to the edge of the plate, and I can get to about 1/8 inch of the plate for this to work correctly. I'm impressed with the detail. I could do this type of detail this small with the plasma. And here's the video if you want to see the rest of the cut of me basically cutting a half a sheet of material.
bye.